Hello guys. Hi, how's it going? Please confirm if you can hear me. Let me see. Okay, I guess I see myself now. Okay guys, how was today's contest? How did it go? And I have a good news as well. I'm running out of charge. So till you talk about how was the contest, let me put my charger, plug my laptop. I feel bad. I solved up to C1, just solved one. Let me bring it. How many of you thought that I won't show up today? You were wrong if you believe that. Let him say in the Telegram channel that maybe you should wait. Meet out me. That was wrong. I'm waiting for more people to join and then we can start talking about the problems. I also am going to release something just now. I mean, at the middle of the solution discussion. Let me just, till more of you join. We are working, guys, really, really hard to prepare this as well. And as you might know, it's taking a lot of time. I mean, we are very fast in general, but this is taking a lot of time from us too. So, guys, we have started, prepared a graph theory intro as well. So you can access them from here too. Graph intro roadmap is also now prepared. I'm just trying to, there are a lot of issues right now. Here it is. Two of them are already there. More are going to be added. And I hope that you like it. And there are some new features as well that we have prepared, especially the Veltos. I'm going to talk more about it today in the Telegram channel. But in general, let me also share my screen. Oh my God, there's a lot. So these are the things that are already there. Graph theory, and it is a new format. As you see, we have changed the UI again. So we are making a lot of change very fast. And to give you a teaser, something else is changing as well. If you come to profile, you see that we have added some new thing named Veltos that, I'm going to talk to you about what they are. We are preparing these as well. What they need is still more work to be prepared. Until topological sort, we have started, but we have not finished them. So these are the roadmaps that we have at the moment. If you guys are ready now, if more people have joined, now we can start talking about the problems of these two. Shall we start? If you're ready, let me know to start talking about the problems. And guys, I definitely put a vote on the quality of the content that we are making as well today in the Telegram channel. Okay, let's talk about it. Let's talk about the problems. So let's start from the first problem. The first problem, Shizuku, Hoshikawa, and Farmlex. It says that we have a farm, and in this farm, we know that how many Shizuku has counted n legs, and we know that each chicken has 2 legs, and each cow has 4 legs. You have to say that how many configurations are possible, assuming that there are n cows there in total. You have to just say that. Because that is the first fact that we can say about it. Definitely, the first fact, I mean, when you look at this problem, the first thing that should come to your mind is this. If n is odd, the answer is 0. That's the first thing that should come to your mind after reading this problem. Because a chicken has 2 legs, a cow has 4 legs. So it's impossible that the total number of legs will be odd. If it's even, first, assume that n is divisible by 4. At the end, in solution, it doesn't matter, but for explanation, I'm just saying it. Assume that n is divisible by 4. Do you agree that we can have n fourth cows and 0 chickens? Or n fourth minus 1 cows and 2 chickens? Or n fourth minus 2 cows and 4 chickens? I mean, we can replace each of the cows with 2 chickens, or up to 0 cows and n half chickens. So we have at most n half cows, and we can replace each one of them with 2 chickens. So we have at least 0 cows. So in total, it's gonna be n fourth plus 1 ways, exactly. Also, if, do you agree with it so far? I mean, if n is divisible by 4, it's like this. If you agree with it, please put a plus or use this emoji. Great. Now, the point is that if n modulo 4 is 2 as well, it's going to be again the same thing. If n, let me write here, if n modulo 4 is 2, it's going to be the same thing. Again, I either will have n fourth floor of it, cows, and 1 chicken, or n fourth minus 1 and 3 chickens, or up to 0 and n half. So again, the number of cows will be up to floor of n fourth, and it would be at least 0. So again, it would be floor of n fourth plus 1. So the whole solution will be this. You get an input, a value n, and in output, if n was odd, you will output 0. If n was even, you will output floor of n over 4th plus 1. That's going to be all for the solution of this problem. Is this clear? If it's clear, please put a plus or use this emoji. If you have any questions about it, let me know as well. Let me also... Okay, so I guess everything is clear. Okay, so let's talk about the next problem. Let's talk about problem B. Problem B. It says that U is trying out the student council. Unfortunately, she's doing to clerical work, and it doesn't matter. You are given a partially filled array of non-negative integers a1 to an, where blank elements are denoted with -1. You would like to fill in the blank elements with non-negative integers, such that the absolute value of the sum of the elements in a difference array is minimized. More formally, let B is so assume that, you want to fill in the blank elements such that if you define bi as a of I plus 1 minus ai for all I from 1 to n minus 1, you have to find the minimum possible value of sum of b1 to b of n minus 1. So you want to minimize this difference array, the sum of this difference array, across all possible ways to fill in the blank elements of A. Additionally, output the array that achieves this minimum. If there are many, you have to find out the one that is lexicographically smallest. So guys, this is a problem that I'm just facing right now. And the first thing again that comes to my mind is that initially we have some difference array, right? Initially we have some AIs. Assume that, for example, in here I have 10. In here, for example, I have 17. And I want to put something in the middle of them. In the middle of them, there's a -1 that I should choose that. What do I put here? If I want to minimize the sum of this difference array, I should definitely put an x here such that x is definitely between 10 and 17. If I put anything that is between 10 and 17, by inserting x in here, the sum of this difference array would not change. Because initially this and this have difference 7, then if I put something in here, that some x that is between 10 and 17, for example, if I put 13, then I will have 3 here and 4 here. It's just like I split 7 into 2 parts. If I put something that is in the middle of 10 and 17, I'm gonna have x minus 10 at first and then 17 minus x. And because x is between 10 and 17, I do not need to put these absolute values because x is definitely at least 10 and x is at most 17. So you can see that the sum of these two will always be 7. It always remains 17 minus 10. So the whole point that exists here, the whole point of this problem is that the elements, the negative ones that you will choose, if you want to minimize the final value of the difference, they should be between the two consecutive elements. Yeah. The absolute value is taken at the end, but I'm saying that assume that assume that the absolute value is something. Before inserting these negative ones, I want to insert those values in the places of negative ones such that it does not increase the final answer. Let me. Oh, okay. Yeah. I get it. So I misread it. Yeah, you're right. This was if I had bi equal to this. Yeah, I get it. What you mean now? Okay, so guys, in this case, this is actually simpler because now b1 is a2 minus a1. These, you can see that they can cancel each other very clearly. b1 is a2 minus a1. b2 is a3 minus a2. And so on. So do you agree that at the end, if we take the absolute value at the end, do you agree that these values all cancel each other and we will be left with an minus a1, the absolute value of an minus a1? Do you agree with this? Yeah, I get it. I'm gonna tell you about that other way as well. If we consider the absolute value between each two, that would be a bit harder, but that is also easily solvable. I will talk about that too. That what if we had this absolute value for each of them? It would be just a bit harder, but it was not important. The whole point of it was that each element should be between the one before and after. But right now it's even, I mean, it's way simpler. So the whole point is that, guys, this doesn't matter at all. I mean, at the end, what it talks about is just that the absolute value of a(n minus a1 should be minimized. So the whole thing that you should look at is, I mean, these numbers really do not matter. Only the first and the last one matter, and nothing other than that. So you can clearly see that. I mean, if these two values are set, the first one and the last one, then for the rest, you can set 0. I mean, anything that is in the middle, just make them 0. Anything that is in the middle, make them 0 because they do not matter. So put them the minimum they can be. If the first one and last one are in a way that one of them is set, one of them is x, you have to set the other one x too, such that their difference will be 0. If none of them are set, you have to put 0 in both places. You want them to be equal, and you want them to have the minimum difference. So you can put 0 in both places. That's all. So this way, even in a simpler way, it will be solved. But I will have a recap of what if the absolute difference was for each two as well. First, tell me if this is clear completely. If it is clear, please again put a plus or use this emoji so that then I will talk very briefly over what if we had these absolute differences for each two. Awesome. Now let me tell you about the version that I was saying that was a bit harder, but still it was easily solvable. What if we had absolute value of b1 plus absolute value of b2 to absolute value of bn minus 1? In this case, guys, the whole thing, as I said, was that if you have some x here and some y here, anything that is in between should be between x and y. Then if I make sure that everything is between x and y, the real absolute difference would stay the same. So the whole thing that you had to do for each of these places that they have an element before them and an element after them, you have to put everything, every empty space that is between x and y, you have to set them to minimum of x and y in that case. Okay. I just want to tell you about the solution of this problem as well so that you get familiar with this too. You have to put minimum of x and y because they would not ruin anything and they are the minimum possible value that they can be. And if you had some empty spaces at the beginning, you have to set them equal to the first non-negative number. And if you had some empty places at the end, you have to set them equal to the last negative one element. And that would be solved as well. Is this clear too? Let me pause this, by the way. Let me pause myself. So if that's clear, let me, no. Because in here, I mean, I basically try to face the problem just in front of you and share with you that what is the mindset that I have when I face these problems. So I hope that it really helps you to see that how you should approach the problems. And guys, by the way, let me tell you this in the middle. How many of you have used the roadmaps that we had so far? Let me ask you about your opinion that you have. Guys, everything that we teach, everything that we put here are all for free. Everything, every educational material that RepoWife has is always for free. We try to fill the gaps that exist and we try to do it in the most amazing way. We want to make a situation that even if someone is in somewhere that has no access to anything, they can easily learn Olympiads, IOI, competitive programming, ICPC. So we have prepared these roadmaps. Many of them are not published yet. because we are working on them. They are not ready. But we have very advanced topics as well and less advanced topics. I just released Graph Theory 1 as well. As you can see, there are some sections that are not ready fully yet. It takes a lot of time because it has a lot of manual work and energy. And at the same time, I myself am on improving the code base as well and adding new features. So if you have used, for now, these are released. If you have used them, let me know about your opinion. I mean, how was it so far? I mean, so far, we had these roadmaps only. And Graph Theory, Graph Intro 1 was released just now, just at the beginning of this live stream. Dynamic programming was the first one that was released, and then shortly after C++ was released and combinatorics. And centered decomposition is the thing that we have bootcamp right now on. So I basically am teaching. We're going to have several sessions. In the next session, we're going to solve a problem from IUI with centered decomposition. So I would like to know that what is your opinion and how was it so far? I mean, I think you can find the link in here as well, the link to the roadmaps. If you had any feedbacks, definitely let me know. I keep asking it in Telegram channel as well. If you think there's any way that you can improve them to be better than this, let me know. With your bootcamp, I become expert today. That actually means a lot, Reza. I'm so glad to hear that. I mean, any of you, I sometimes see some posts on LinkedIn that people share and they mention me, and they say that they have went to the, I mean, they reached some level. That's great. That's really great. I mean, that's the best thing to hear. Make video on tree. I mean, in this roadmap, we are exactly gonna talk about tree. I mean, in this graph theory intro, we are talking about tree as well. It's gonna be the section number 6. After DFS, BFS, applications of it, shortest path inverted graphs, Dijkstra, and then trees, and then DSU, and then MST, and then topological sorts, and more will be added. But they require more work. It's really taking a lot of time. I mean, because I'm kind of a perfectionist and I try to make them really to a state that they get perfect and then release it. That's why we have a lot of things that I'm not releasing them yet. So, thanks, Barth. I mean, I'm really glad to hear that. I'm really glad. I will definitely will do. So, guys, definitely let me know about your opinion. We want to make everything amazing. That's the standard that we are committing to. We want everything to be amazing. So if you have something and you believe that it's not amazing, it's just good or something, I mean, or it's bad, or it's just good, let me know. We should improve it. I mean, because our goal, the reason that we are in this world, the reason that we came to this world was to create amazing things, right? So if something is not amazing, we have not done it correctly. So we have to fix it. And thank you guys. Thank you so much for the hearts. Right now we are going to problem C. So let me bring problem C. In linked DFS and graph theory is showing. How's possible? Let me check it for a second. In the link, if you copy the link, let me open the incognito tab. It shows you all the ones that are prepared so far. There are 8. Sorry, there are 5. My mind is not working anymore. Okay, so let's talk about problem C. I know that a lot of you are waiting for problem C, so let's not keep you waited more than this. Let me bring problem C. First of all, when I open the statements, I don't feel good. I don't like the problem that their statements are very long. And if you know me, if you have been in my session, you see that most of the problems that I tell you and I give you are the ones that their statements are shorter. because they're usually better problems. But anyway, let's see that what it is. Uh, it is the easier version. The difference between these two versions is that in this easy version, AI and BI is at most one. It says that Renako is stuck between a rock and a hard place. And by that, of course, I mean Ajisai and my... Okay, and my both of them want to hang out with her and she just can't decide. They have to play the XOR game and they are given arrays A and B of length n. AI and BI are up to 1. They will play a game that lasts for n turns, where Asijai moves on odd numbered turns and Mai moves on even numbered turns. On the turn number I, the player, to move may choose to swap AI and BI or pass. Note that if a swap occurs, the index that is being swapped must match the turn number. Okay, so in the first place, AI A1 and B1 can be swapped by Asijai. And then A2 and B2 can be swapped by Mai. And so on. Thus, only Asijai can swap odd indices and only Mai can swap even indices. At the end, Asijai achieves a score of A1 XOR A2 to AN, and Mai achieves a score of B1 to B2 XOR B2 to BN. The player with the higher score wins. If the players have the same score, the game ends in a tie. Determine the outcome of the game with optimal play. Okay, so guys, again, the first thing that comes to mind, what is it? When I just read this problem. I read the problem just in front of you. So everything that comes to my mind is the things that came to my mind right now. So what comes to my mind right now is that when can they end up in a tie? They end up in a tie if both of them are 0 or both of them are 1. Which means that in total, they will be equal if in total we have even number of ones. If we have even number of ones, what is XOR? XOR means that what is the parity of the number of ones they have. Because everything is between 0 and 1, XOR means the parity of the number of ones that they have, right? So if in total we have even number of ones, then either both of them get odd number of ones or both of them get even number of ones. So at the end, their final score will be the same. So if we have even number of ones, definitely the game is going to be a tie. Otherwise, if we have odd number of ones, definitely the game will not be a tie. Someone will win. Is it clear so far? No. I haven't read this problem C yet. I'm just reading it and I'm solving it in front of you. We will see. We will see that's how far we can go. So is it clear, guys? So the whole thing is that when we face this problem, we can say that, okay, if we have even number of ones, it will be tie. It will be a tie, definitely. Otherwise, one player will win, definitely. So that's the first thing that comes to my mind when I see such a problem. So now we should see that, okay, so the whole question that will be left is this, that if we have odd number of ones, who will win? For that, we should consider the last position that is meaningful. What do I mean by meaningful? Some positions are not meaningful. Why? Either both of them are 0 or both of them are 1. Then that position is not really meaningful. That action is not really meaningful. It doesn't mean anything, right? Because they cannot do anything important. Let's consider the last position that is actually meaningful. One of them is 0, one of them is 1. And the player can swap these two. I say that the person who owns that last meaningful action will win the game. Why? Because the other player cannot do anything after that. Every other operations are meaningless. This position is the last meaningful position. So he can see that if he needs a 1, he can choose the 1 for himself. If he needs a 0, he can pick a 0 for himself. So the whole thing is to just look at the last meaningful position. And then we can say that the player who owns that last meaningful position will win the game. That's all. Is this clear? No, I think that it's definitely, I mean, guys, I've talked about it a lot. You have to face a lot of problems and see a lot of patterns. I mean, for this contest, I didn't have time to read the problems in advance other than problem A. I just read problem A very shortly before the starting the stream. But for example, problem C, I read it in front of you. And you can see the exact thinking process of me. This is usually not allowed. In the previous live streams, I was reading the problems in advance. But right now, in this live stream, this can be a good test tool to see that if you like it better this way, that I face the problems in front of you, or do you like it if I read the problems in advance and just tell you the solutions? Because this way you can just see the thinking process of me. I just read the problem in front of you. I also read B in front of you, and you saw that I first misread problem B. I read problem C1 in front of you and just shared my my thinking process. When I see it, I said, okay, because I saw these patterns many times in different problems. This comes when you solve a lot of problems. If you see my Codeforces, I have solved 2,600 problems or so. This is how you can get it. Not that if you just started competitive programming, you can do that. And I'm trying to solve this issue. I'm trying to make a situation for you to be able to do the same thing and to learn it correctly. And I'm definitely trying to design the roadmaps that it will reach this goal. I hope that we can really do something great there. Last meaningful, but I couldn't think of. Yeah. Why the last meaningful? Why? Because the last meaningful is the most strategic one. When you are playing the last meaningful, all the previous one are decided. So you can see that what is the state so far, right? The last meaningful is the deciding one because all the previous decisions are made and you can see the result of them. Now, when you come to the last one, you can see that, okay, right now, am I losing or am I winning? If I'm losing, I will swap these two. If I'm winning, I just keep it at this, as is. And the other player, I'm sure that after this cannot make any change. So why the last meaningful? Because the last meaningful is the real strategic one. Because the player yeah, exactly. So if you are winning, if you have the last meaningful position, if you are winning already, then you are winning. So you pass. If you're not winning, you just swap. And you know that the other person cannot do anything. I try to watch my language. So the other player cannot do anything. Can we say that if there is no meaningful position, then this is a tie? If there is no meaningful position, it's definitely a tie. Why? Because definitely the number of ones will be even. If there is no meaningful position, then definitely the number of ones is even because each position either has 2 ones or 0 ones. So you can see that the total number of ones will be zero. Will be even. Modulo 2 will be 0. So if there is no meaningful position, it definitely means that we definitely have even number of ones, not odd number of ones. So that it definitely is gonna be a tie. Let me bring my. Is that clear? If both players have the same amount of meaningful position where they can swap with. No. As I said, it doesn't matter how many meaningful positions you have. It doesn't matter. Only the last one matters. Because the last one is the deciding one. Even if you own all the rest and I own the last one, I will watch that how you play on the rest and accordingly I will choose the last one. So even if you own everything else and I will own only the last one, I will Just decide for the last one according to how you decided for the previous ones. I see that, okay, you did some actions. Am I losing right now or am I winning? If I'm winning, that's good. I will pass. If I'm losing, I will swap this two. And then the parity of the number of ones change in both of them. So only the last one matters. The number is not useful for you. I mean, even if you have all of them, I have the last one, I'll win. There are other test cases. Test case 3. Let's take a look at test case 3. If you take a look at test case 3, you see that we have even number of ones in total. So we have 4 ones in total. In total, right? I'm saying that in total, how many ones do you have? Not in one of the arrays, in both arrays. How many ones do you have? There are 4. So when there are 4, I say that either both of these will have even number of ones or both of them have odd number of ones. Either at the end it would be 0, 4, or would be 1, 3, or would be 2, 2, or 3, 1, or 4, 0. You see that in all of them, the parity of both sides are the same. Why? Because the sum of these two should be 4. So the sum is even. When the sum is even, they should have same parity. So the score of both of them either will be 1 or will be 0. So that's exactly one of the cases. Yeah, I mean, the last one is the strategic one because this is the last action. I've seen what you've done so far. I can say that already am I winning or losing? And I'm sure that after this, you cannot do anything because all of your other ones are meaningless. How can I contact you with you? On LinkedIn, I'm talking to a lot of you. Have I talked to you on LinkedIn? To a lot of you, I'm talking on LinkedIn and I'm asking your opinion about RepoBot and how can we make it really amazing. If there's anyone, I mean, if I have talked to you on LinkedIn, let me know. If you want to talk to me on LinkedIn, you can just connect with me on LinkedIn. I think my LinkedIn should be here somewhere. It's not here. Also, I forgot to update the Instagram page. I mean, we have Instagram page for RepoVive, but this is not updated. This is my personal. I should update that. My LinkedIn should be somewhere. The link of. Anyway, I mean, at the end, even if you cannot find my LinkedIn, you can just search my name. And it will give you my LinkedIn. This is my name. You can talk to me on LinkedIn. If you want to talk to me on somewhere other than LinkedIn, you can. One of the things you can do is to join these teams in RepoVive that we have a lot of teams. And guys, these teams is also something that I thought would be really useful for you. Let me tell you about this very quickly because I believe that that's something that can really add value to you. I know that many of you live in places that you don't have people around you that are studying CP. And that's really bad. That's one of the pain points that I recognize and I believe that we should fix it. This is a position that you can find like-minded people. For example, we have a team that already have 1 or 2 members that reach pupil. I mean, people who want to study together to reach pupil, or if you want to reach a candidate master. And you can create your own team and invite others to join that. And you can keep it open to everyone or just being request-based. And there's one team there as well that is build and learn with RepoVive. If you want to build and learn with RepoVive, then I will try to help you grow in this field, in this building amazing things. We are together trying to build amazing things. If you are someone who's really passionate about it, you can join this. And there's a level 0 that we give you some small tasks and see that how you do, how you act. And if you were really passionate and you really did them well, you will promote to level 1 and then level 2. And maybe someday you become a core member of RepoVive. So that's how I try to make it this also accessible to everyone. I think the whole point of everything is to make it everything accessible to everyone. 1 or 5 people are already there and we have 6 join requests as well. So if you want to be more in contact with me and do more stuff and build and grow together, because we do a lot of research of what should we build, how can we really be amazing and stuff, you can be there. But I mean, it takes some time as well. I mean, we are very busy with everything, so it takes some time to manage all of this too. Uh, okay, let's get back. I actually have you written but couldn't connect with you. Have you requested recently? Sure thing. We try to go way beyond streams. Now we are trying to go over this community and do more amazing things. We can check AX or yes, if XOR of A is equal to XOR of B, we will return type. Because that's exactly the same situation as having an even number of ones in total. It depends if you requested to join some team, it depends on the owner of that, the one who made it, when to, actually respond to that and check if you have to approve you. You can build your own. I mean, if there's already one candidate master one, you can build another one, and you can keep it open to everyone, or you can also make it request based. This is maybe some people want to make a team for themselves. Maybe someone is looking for having maximum number of people, 5 people. So then that person will just take 5 people and those 5 people will start. You should make another one then. So there's no limit. I mean, if there's one candidate master, you can make a new one and new people will join. I forgot what was the question. I think that I was answering the question. Okay, I was answering the question how to talk to me. Okay, yeah. So, okay. My Codeforces ID is Cheyenne, but I'm more active on LinkedIn. In the past 2-3 days, I was not active on LinkedIn. But in general, I'm active on LinkedIn. I'll be back on LinkedIn. I was very busy with just adding these roadmaps and improving the websites. I couldn't be on LinkedIn. But I'll be back and I'll continue. I see the new batch of people who try to requested to connect with me there, and I will talk to them. And I ask that what is how we can improve it. Okay, you're talking to Solaris. I got it. But okay, the last one also ends up to tie. The last one, if you mean this does not end up to tie because there are odd number of ones. And if you look at the last meaningful position is this. It's position 4th. So Mai will win the game because he controls the even positions. Is it completely clear, guys? Shall we move on to problem C2? Let's just not to make you more weighted than this. If it's completely clear and you should move to C2, let me know. If you have any last questions about C1, let me know. Awesome. Let's move on to problem C2. Again, problem C2, guys, even before reading it, I have some ideas about it. And I will share it with you. Now AI and BI are up to 10 to the 6, and I think that's the only difference. Guys, we just talked about when the game ends up in tie, right? We just talked about when does the game end up in tie. When does it end up in tie? When we have even number of ones. So again in here, when we compare the XORs of two numbers, the first thing that matters is the most significant bits. Again, I'm just sharing with you the first thing that comes to my mind. Is that nothing other than the most significant bit matters. If in the most significant bit, someone can win the game, then that player is the winner, even if the other player gets all the other bits. So I will just take a look at the most significant bits. I will just take a look at the most significant bits. And if I had even number of them, I know that in the most significant bit, they are gonna tie. So I'll move on to the next bit. If I had even number of these, I know that they are gonna tie on this bit. So this bit actually doesn't matter because at the end, they will have same value in the here. If there was even number of ones in this position, I'm considering the binary representation because it's XOR. Definitely, the first thing that comes to my mind, to our minds, is that consider the numbers in binary representation. The most significant bit, if you have even number of them, then it doesn't matter actually. If you have even number of ones in all the numbers, in all the 12 numbers, n numbers in A and numbers in B. In this position, we have even ones. This doesn't matter. We go to the next one. If it was odd, this can actually make the difference. So what is that? What is the main thing? I should find the most significant bits that I have odd number of them. This time I call this the most meaningful bits. This is the most meaningful bits. These bits are meaningless because at the end they will tie. We just talked in the C1, that's why they are meaningless. C1 was actually a great hint for problem C2. We say that we know that the bits that we have even number of ones in them, they're meaningless. Now I consider the most significant bit that is meaningful, and then only that bit matters. And this will turn each number into 0 and 1 because from each number I just care about this bit. And I can solve it similar to problem C1. Is it clear? If it's clear, please put a plus or use this emoji. Thanks. Yes, that's as because when you solve C1, C2 will be very clear. You can just say that, okay, at each, just consider the most meaningful bits. The bits before that are meaningless because we just talked that they end up in tie. Anything we do, they end up in tie. So it's just about how many of them, the first bits that we have, odd number of them, and just play on that bit. If you have any questions about that, let me know. Otherwise, we'll move on to read problem D. How can we check the most significant bits? Can we see some code? Yeah. In order to check the most significant, the most significant, meaningful bits, what you should do in general, if you want to count, if you have some number x and you want to see if bit number I in it is 1 or not. Let me first explain this to you and then I will show you some code as well. We will try to find some code that implemented the same idea. If I want to see in some number x, bit number I is 1 or not, I can just do this, x shifted to right by I and 1. That's how we can find out if bit number I in x is 0 or 1. So you will have a 4 on I from the most meaningful bit. From bit 20, because the numbers are up to 10 to the power of 6, I can go from 20 and go to 0. I can even start from 19. But anyway, it doesn't matter. I go over all numbers then, and for each AI and BI, I will check A, for example, let's call this B. For each number, AJ, I will check AJ shifted by B and 1. If that happens, I will say CNT++. At the end, I see that if CNT was even, continue. Move on to the next bit. This bit is not meaningful as well. If it was odd, just work on this bit. And then turn each number into this, and then you will face with numbers that are not 0 and 1, and you can solve it like before. You can then see that what is the last strategic point that can actually have meaning on this bit, because this is the first important bit. Let me also show you some code so that to make sure that you're completely okay with it. And if there is none, then it's a tie. If there is none, it's a tie, exactly. Yes. Yeah, this also works. 2 to the power of I and x. That also works. I will explain it once again from the solution. From the code that helps you to completely understand it. I want to try to, these are Python. So maybe this code. Yeah, this code looks beautiful. So let's see that what does this code do. Here here he gets all the test cases and he voice series. He is getting all the AIs and he says C1 XOR equal to AI and C2 XOR equal to BI. And if C1 was equal to C2, see outside. What does C1 equal to C2 mean? Actually, if instead of C1 and C2, if we had just C, if in both of them, instead of C1 and C2, he was writing C, actually this if would turn into if C is not, if C is 0. What is that? Does it check? I mean, it says that it's checking that what is the XOR of all the numbers in A and the XOR of all the numbers in B. If they are equal, it means that in each bit, the parity in A and the parity in B are equal. So in total, for each bit, we have even number of them. If instead of C1 and C2, we have only C, it was just enough to say that if C equal to 0. That means that all the bits, we have even number of them. Then it was a tie. Okay, so is it clear so far? Why does he use function solve? The main reason he uses function solve, this is not my code, but the main reason he's using function solve is that we have several test cases. And for each test case, he's calling this function solve. And he will go over them. So because it will be repeated t times, he will call the function t times. Okay. That's one way of coding it. Then he will start from the last bit and goes back. And he actually, this is again, C1 XOR C2 is that C that I was talking about. He could just, again, instead of this, have C. That was also correct. This is also correct. But I'm just saying this was also correct. He is finding the first position in C, that's the first bit, that is, we have odd number of them. Okay, he finds the first position that we have odd number of them, and once he found that, he will start from n minus 1. I think he didn't need this or k equal to 0 as well, because there definitely will be some position, some such position. So by the time that we come to 0, we definitely, some of them hit here. So I think this was not needed to. Anyway, we say that if AI shifted to right by k and 1 was not equal to bi shifted by k by and 1, this is finding the last meaningful position. He's starting from the end and goes back. He tries to find the last meaningful position. If they were not equal, if I modulo 2 was 0, if it was the Asijai's play, he will see out Asijai. If it was my play, he will see out mine. And that's all. And if you do this at the end, you will get accepted. Okay, so that's all about this problem. Or k equal to 0 is doesn't matter. That has no effects. I mean, if you copy and paste this and just remove this or k equal to 0, you see that it again gets accepted. Just forget about it. It's just, it has no effects. Yes, again, the last meaningful position. Yeah. I don't know why the people who solved C1 were unable to solve it. Yeah, the main point in C2 was to extending it to all the bits. Let's say that, I mean, the most meaningful bits, the significant bits, if we have odd number of them, they are meaningful. If we have even number of them, they are not meaningful. They will end up inside. Yeah. Okay, so if you want, now it's brings, after I'm reading this, the first thing that comes to my mind is to create a roadmap for bit operations. Yeah. Yeah, I mean, C1, C2 does not matter that much as well. I mean, C1 and C2, if you take a look at it, wherever he used C1 and C2, he's working with C1 X or C2. I mean, this also is actually working with C1 X or C2. He's checking if C1 X or C2 is 0. So he does not use C1 and C2 actually. He's using C1X or C2, I believe. So all the places that he uses it, he's using C1X or C2, so he could also use C. This is completely correct as well. I mean, this is completely correct as well. But the way I'm explaining it is that you could use a C instead. You could just keep a C. I mean, in here, he separately calculates all the XORs in A, all the XORs in B, and then XORs the results. That was the same that if from the beginning we would calculate the XOR of everything. What if in the attempt to win, player blunders a higher? The point is that the higher bits definitely end up in tie. We know that about the higher bits, we have even number of them. So they definitely end up in tie. So we don't need to worry about them. This is the first bit that does not end up in tie. So the other player cannot somehow win in the higher bits. Yeah, C2 was not very hard. About bit operations, not yet, but now that you talked about it, I'm thinking about writing one. At the moment, we have this. At the moment, we just have this 5 released. This graph one just released, and as I said, it's using a new UI. We have different sections. This is the first time. So as you see, not only we are fast in, I hope that you enjoy how fast we are moving. We keep changing the UI as well. I hope that you like it better this way. So for each of the for each of the sections, we have one separate space, and you can start from each section. Maybe someone doesn't want to read the first section, wants to read a more advanced section, they can do that too. Okay, that's great. Let's tie only if higher bits are tie in any case. I mean, however they play, the higher bits are gonna end up in tie. Why? Because we have even number of them. So either both of them will have odd number of that bit, or both of them will have even number of that bit. So it will be tie. Sorry guys, I mean, I don't get enough sleep these days, as you might know. I don't do anything other than working. So sorry if I'm not at my 100%. Can we see how the XOR and most significant bit is working with the first test case? Yeah. So on the first test case, let's start with the third bit first. In here, the most valuable bit is the third bit. The third bit for 1 is 0. For 4 is 0. For 6 is 1. For 1 is 0. The third bit. I mean, let me write the full binary representations. 1 is 001. 4 is 100. Yeah, I made a mistake. In 4 was 1. For 6 is 110. For 1 again is 001. For 3 is 011. For 2 is 010. For 3 is 011. For 7 is 111. 111. So first we consider the most significant bits. These bits. How many ones do we have in here? We have 3 ones, yeah. So this is the bit that makes the difference. If I had 4 ones, for example, this was 1, 2, then this bit would not make a difference. Definitely at the end they would have the same parity in A and B. So definitely this bit did not matter, and we would go to the next one. But in here we see that the most significant bit, we have odd number of it. So some player should win here. So Now, if we consider the last position, you see that the last position is the last meaningful action for this most significant bit. And it's the fourth position. It's an even position. So the one who controls the fourth position will win the game because he controls how the most meaningful bit will be decided. So Mai will win the game, if I know his name correctly. Mai will win the game. That's an example. Why lower bits don't matter? Because if you take the higher bits, even if the other player takes all the lower bits, it would not be as big as yours. So if you take a higher bit, if the other player gets all the lower bits, it wouldn't be as high as yours. Is Codeforces okay? No, it's not. Yeah, it's 404 for me as well. That's a bad thing because we don't have the problem statements of the next problems. But I guess it just became like that, and hopefully very soon it gets fixed as well. Yep. It's not working. Okay, is it completely clear? Problem C2? If you have any questions, let me know. Otherwise, put a plus or use this emoji. Awesome. Great. Great. And guys, Repovive contest is gonna be this weekend, but I realized that we realized that there is again a Codeforces contest on the same day that is our contest. We have our own judge, and the contest will be hosted on Repovive website. We have our judge ready. I'm gonna announce the judge as well today on Telegram, and you can test the judge. You can submit your solutions. I will put a problem there so that you can test the judge with it. A simple problem that you can test the judge with. So we have our own judge now, and the contest is planning to be on Sunday, but since there is a Codeforces contest, it doesn't make sense to be at the same time that Codeforces contest is. It's meaningless. So we will change it if again we will change it. If again we don't change it to a time and then we realize that again there's a Codeforces contest on that day too. CF is now okay, great. Ready for DDD. Good. Awesome. So let's talk about problem D. TRE. What is TR? Okay. So let's talk about problem D. I like this statement. See, it's short. Even though the previous problem was good as well. I like the previous problem. It was a good problem as problem C. This is the easy version of the problem. The only difference between the easy and hard version is that the hard version asks you to construct an example of a satisfactory tree. As an earth mage, Ray has mastered the spell of growing trees, but Manoria brags that she can grow a more impressive species of trees. Why it kind of feels to me like ChatGPT has wrote the statements. These M dashes, I don't know if you're familiar with this or not. These M dashes are ChatGPT's or AI sign. Whenever that you see an M dash, whenever I see an M dash, I feel like ChatGPT has wrote it or some other AI. Why do we have M dash? Manaria brags that she can grow a more impressive species of trees and remembers that most rare type of tree can be grown using a formula represented by a certain permutation. You are given a permutation P of length n, determine if there exists an undirected tree with n vertices labeled 1, 2 to n, satisfying the following condition. Let U and V be any two vertices connected by an edge, then U appears before V in P. What? Let U and V be any two vertices connected by an edge, then okay. Okay. Then U must appear before V in P. It's just yes or no. Okay. So this problem says that we have a permutation P and we have a tree. We want to construct a permutation P. And we want to see that if such... No, we want to construct a tree, sorry. We have a permutation P. We want to construct a tree such that if there is an edge between two vertices like U and V, they should be in order in the permutation. I mean, if U is less than V, U should come before V in permutation P. So it's like if there's an edge between these two numbers cannot create an inversion. Right? That's the main thing. Again, I'm facing this problem right now, and you're gonna see the thinking process that I have when I face this problem. It depends. I mean, we have at most 40 minutes till I have to give up the room. And maybe we should not count up on the last 5 minutes or 35 minutes. Let's see that's where we can achieve. So, guys, the first thing that comes to my mind is this. If we just consider the permutation and add an edge between each two positions, that they are not inversions. So for each two numbers that they are not an inversion, if we add an edge, then if there's a spanning tree, there's a spanning tree on these graph that we made, if there's a spanning tree, then the answer is yes. Otherwise, the answer is no. So the whole thing is that I have to, for example, let me bring an example. Consider this first permutation. I will consider all the pairs such that they are not inversions. By inversion, I mean that the smaller value comes first and the larger value comes after. For example, 1 and 3 are a good pair. First, we have 1 and then 3. 1 and 4 are a good pair. 1 and 5 are a good pair. So I will first find out my good pairs. By good pair, I mean a pair that they actually can have an edge in my tree. And then 4 and 5 are good pairs. 4 and 6 are good pairs. 5 and 6 are good pairs. 2 and 6 are good pairs. If I just create these good pairs, I draw these good pairs. At the end, if there's a spanning tree, for example, in this example, there is a spanning tree. If there's a spanning tree at the end, we can say that the answer is yes. If there's no spanning tree at the end, the answer is no. For example, I think that in the second example, there's no spanning tree. 3 will be connected to 4 only, and 1 will be connected to 2. There's no way that we can make a tree out of it. So the answer to this one is yes, the answer to this one is no. Is it clear what I'm saying? If it's clear, please put a plus. Otherwise, put a minus. And if you understood, use this emoji as well. Spanning tree means that I can choose some of the edges such that they will form a tree. A spanning tree is having some edges such that we can construct a tree. I mean, we have some vertices. Let me tell you what the spanning tree is. We have some graph, some vertices, and some edges between them. A spanning tree means that we choose some of these edges that they will construct the tree that has all of the vertices. For example, In this example, a spanning tree can be this edge, and this edge, and for example, this edge, and this edge. These four edges can be a spanning tree. It's a subset of edges that if I choose, they will construct a tree. Spanning tree is just a fancy word that says that can I find the tree out of it or not? The way that I can say it is this. I have a graph. Can I pick some of the edges that I construct a tree out of it or not? I have some set of possible edges. These edges are possible. The rest are not possible. Out of these possible edges, if I can use only these edges, can I make a tree or not? For example, in the second case, you see that I cannot make a tree because there's no way that I can connect 3 and 4 to 1 and 2. So I can never create a tree. A tree should be connected. I can never make them connected, right? Is it clear now? The spanning tree parts, remember, forget the fancy word. Just understand what does it mean. I have some edges. I want to say, can I take a tree out of it or not? And how can I check if I can take a tree out of it or not? How can I check that? Easier approach was reverse. I will talk. Yeah, we will reach here. Exactly. Knowing all possible edges and select n-1 to construct trees. Awesome. So now, what is the condition that we can construct a tree? You can see that the whole condition is that the graph should be connected. If the graph is connected, I can create a tree out of it. I can just pick n-1 of the edges such that at the end they will. Each time from each cycle, if I have a connected graph, I can always remove some of the edges that I will end up with a tree. How? Each time I can choose a cycle and remove one of its edges. I can keep doing this as long as I have cycle. At the end, you can see that after removing each of the edges, still I have a tree. So it will be connected because it was a cycle and we removed an edge from a cycle. Connectivity does not change. So if I keep doing this, at the end I will end up with a tree. So I mean that if you have a connected graph by creating this graph, if you have a connected graph, then the answer is yes. If the graph is not connected, the answer is no. Is it clear? If it's clear, please put a plus, otherwise put a minus. No, I will talk. I'm just talking theoretically. I'm not saying that let's construct this tree, this graph. I'm just saying that this is the intuition. This is theoretically. Now we will see that how we can. Yeah, that's a very important part. That's if you have a connected graph, then you can create a tree out of it. Each time you can from a cycle just remove one edge. So now the question is that is it connected or not? How can I check if it's connected or not? Again, we will think. At each position that I come, I know that I will add an edge. Each element that will be added, it will connect an edge to everything that is smaller than it and is to the left of it, right? And for example, if you assume that, for example, 1 is somewhere, then 1 has an edge to everything after it, right? So everything that appears after 1, they are connected to each other. Everything that appears after 1, they are connected to each other, right? Now again, consider everything that is in here. Either the whole thing is connected, or as soon as it's not, the whole thing is not connected. Again, takes a minimum in here. If you take a minimum in here, everything after that minimum will be connected to each other as well, and so on. What I'm trying to say, my intuition at the moment, if I have not made any mistakes, is that the connectivities will be in ranges. They will be consecutive elements that will be connected to each other. That's my intuition right now. And I think the proof is not hard. Uh, how can I show this? See, I basically want to say that assume that some graph is not connected. I mean, assume that for some graph is not connected. I want to show that there will be at the end some border that everything that is to the right of it is not connected to everything that is to the left of it. And then we can check this very easily. We can check this connectivity very easily if we show this. So what I have in mind, my intuition when I look at it is that at the end, if we take a look at each example, for example, in the first example, my connected intervals are this and this. In the second example, 4 will be connected to this 5, 3 will be connected to this 5, 1 will be connected to this 2. So our connected components will be like this and this. So the whole point is that at the end, our numbers will be in consecutive ranges. I mean, our intervals. Let me see if I can show it this way. If I have A1 in here, A1 will be connected to everything that is greater than A1. So everything from A1, every number from A1 to N is gonna be in here, right? Okay, yeah, this is a good way to show it. Yeah. This is a good way to show it. So as soon as I have A1, let's talk about the numbers. Let's talk about the values. Value 1, value 2, 3, 2, N. See, if I have A1 here, I know that everything from A1 to N are gonna be connected to each other. Everything from A1 to A1 to N are gonna be connected to each other because A1 has an edge to all of them, right? So for example, in this case, I have 4 at the beginning. Everything from 4 to N will be connected to each other because 4 has an edge to everything greater than 4, right? So 4 and 5 will be connected. Is it clear so far? Are you following me? If you're following me, I have the proof now. If you are following me, please put a plus or use this emoji. I think the proof is okay now. So I say that if you consider A1 at the first position, everything after A1, every number greater than A1 has an edge to it. So all of them are going to be connected, right? Then what I can say is this. Just continue going forward and at some points you will see these numbers that are greater than A1. If at some point before seeing all the numbers that are greater than A1, you will see something less than A1. For example, if you see some X here, such that X is less than A1. And before it, you have not seen everything that is greater than A1. So it means that there is still something greater than A1 after this. Then I can say that X belongs to the same connected component as well. Why? Because X is less than A1, so it's less than this number that is greater than A1 as well. So X will be connected to this, right? X will be connected to this. So X will be in this connected component as well. And everything greater than X will be connected to this as well. So it's right. It's like appending everything, expanding it to X. If you saw some X here, consider the first number that you see and it's not greater than A1. Because we still have something greater than A1 after this, we know that X will be connected to that. Also, X will be connected to everything else that is between X and A1 as well, because they have not appeared yet. So everything greater than X now is in the same connected component as well. So it's like we are expanding this. Again, if I have not seen everything that is greater than X, before that we see something that is less than X, like Y, then y is in the same connected component as well, because it will be connected to this, and it will be connected to everything greater than this as well. So it will expand to everything that is at least y. Is it clear? I will show it on an example as well. Yeah, we are just trying to check if the graph is connected or not. We are just trying to check that. And for that, I'm saying that we start from the beginning and go forward. And it's like first, A1 will be connected to everything greater than A1. Yeah, sure. No worries. It's not very, it's it needs thinking to understand well. Let me show it to you in an example. Let me see how can I have a very good example. Assume that I have this array 6, 9, 8, 4, 7, 2, 5, 3, and 1. Have I wrote everything? Yes, I wrote everything. So let's consider all the numbers now. I want to show you exactly on this example how would everything work. I have 1, 2, 3, 4, 5, 6, 7, 8, and 9. First of all, I say that I have 6 at the beginning. 6 will be connected to everything that is greater than 6. So I can say that the numbers greater than 6, now they are all connected to each other. I mean, they are a connected component, definitely. Because 6 is connected to all of them, so they are all connected now. They are connected components. And then I come to this 9, and nothing happens. I mean, it's not important. It's in the same component as 6, and then I come to this 8. Now, the thing that x that I was saying was here. I get to some x, like 4, that 4 is less than this 6, and I have not yet seen everything that is greater than 6. So I reach a number that is less than 6, and still there are some numbers left that are greater than 6. In this case, I say that 4 is in the same connected components to y, because 4 is less than 6, and there is some number left that is greater than 6, so 4 is definitely less than that, so it will have an edge to that. There's a number after it that is greater than it, so it will be connected to that. And not only 4, but also everything greater than 4 has that situation as well. Everything that is between 4 and 6 as well. Because 4 is the first number less than 6 that I have seen so far. So the numbers between 4 and 6 will be seen later. So 4 will also be connected to this 5. So I can say that this range expands to 4 to 9. If it was 6 to 9 before, now everything from 4 to 9 are connected to each other. And now my x is 4. Now my x is 4, right? And then again, I will see that I will just continue doing this. I'll get here, it's 7, I will continue. I get here and it's a 2. Again, I see something less than x. Less than, my x is now 4. I've seen something that is less than 4. And I have not seen everything that is greater than 4 yet. So there's something later that is greater than 4. So this is less than 4. There's something later that is greater than 4. So this will definitely be connected to that. Because it will be connected to that, it will be connected to these components. And not only 2 will be connected to these components, everything between 2 and 4 will be connected too. Because 2 will have edges to them as well. So it's like it will expand my range to here. 2 to 9. Now. And at the end, you see that 2 to 9 will be one connected component, but a single one will remain at the end that is not in the same component. So is it clear now? I start with some x and go forward. Whenever I see everything that is greater than x, we're done with that interval. But if I have not seen everything that is greater than x, before seeing everything that is greater than x, I see something that is less than x. Then it adds everything more than x to this interval. Is it clear? Crystal clear? Awesome. I mean, if you understood it, the rest of you as well, use this emoji, please. Or put a plus and ask me questions if anything is not clear. Yeah. I mean, it gives us great intuition about what the tree is as well. I mean, I have not thought about that, but we will go forward together. I have already some intuitions about how to construct the tree. The idea is, I mean, how does it look like implementing seems a bit confusing. We will definitely talk about it, no worries. We'll definitely explain. Can you show code part? Yes, I will show code part as well. It's just a for loop. Yeah. Actually, at the end, it will be like that. I will reach the implementation. The implementation is not very hard. I'm just explaining. I have not talked about implementation. I first talked about we have a graph and we have to find if it's connected or not. And then I said that it's equivalent to this. And it seems like it's clear to everyone now. So the whole thing is this. I have an x. I start from the beginning. If I've seen everything that is greater than x, then that's good. Yeah, if I see something that is less than x and I'm not completely done with it, I mean, I'm not completely done with everything that's greater than x, it will expand this interval. So assume that at some point we stop, we cannot expand anymore. How does it look like? It means that for some x, now we have seen everything that is greater than x, and we haven't seen anything that is less than x yet. So how does it look like at the end? It means that like in our array, we have seen some interval and we have seen everything that is greater than or equal to x, but we haven't seen anything that is less than x. Because if we would see something that is less than x in there, we would expand that interval. So at the end, our graph is not connected if and only if this happens. There will be a prefix that everything would be greater than or equal to x and a suffix that is less than x. So there should be a prefix and a suffix that all the values in this prefix are greater than or equal to all the values in this suffix. At the end, we will reach here. So we should only check this. Is there, and let me show you on an example as well. At the end, we should just consider this. If there is some prefix such that everything in this prefix are greater than everything in this suffix. Also in here, if there's a prefix that everything in this prefix is greater than everything in this suffix. If that exists, then the answer is no. Also in here, we see that this prefix, all of them are greater than this suffix. So this is yes, this is no, this is no. For this one, it also doesn't exist. So yes, this is no. For this one, doesn't exist. So yes. For this one, doesn't exist. Yes. So it will be yes, no, no, yes, no, yes, yes. Yes, no, no, yes, no, yes, yes. That's exactly what you said. Yes, no, no, yes, no, yes, yes. So the whole thing is this. If there should be a prefix and a suffix that all the values in this prefix are greater than all the values in this suffix. Thank you very much. I'm glad. I hope that I can use it in a way that actually makes a great difference. If x less than 6 comes, then 6 to 9. Yeah, I mean, if something less than 6 appears, then everything greater than that number will be connected to this as well. Yes, the decision problem is even easier. We can just do this. For each suffix, just calculate its maximum. See what is the maximum of this suffix. Okay. So for each suffix, calculate that what is its maximum. Start from the end and calculate that what is the maximum of a suffix. Consider the suffix of length I. How it would be disconnected from the rest if and only if all the numbers in here are from 1 to I and all the numbers in here will be from I plus 1 to n. So the final solution would be as easy as this. For each suffix, just calculate its maximum and see if it's equal to its length. For example, if the last suffix, if the suffix that has only one number, if its maximum is 1, it means that if 1 is at the end, or the maximum of the last two numbers is 2, or the maximum of the last three numbers is 3, or the maximum of the last four numbers is 4, and so on. Or the maximum of last 5 numbers is 5. Just check all of these. If one of them appeared, if one of them happened, then the answer is no. Otherwise, the answer is yes. That's all. Let's get back to these examples. In here, we can see that the maximum of last two numbers is 2. So the answer is no. In here, also the maximum of the last two numbers is 2. So it's no. In here, again, the maximum of the last two numbers is 2. Also, the maximum of last one number is 1 as well. Both of them are bad. So it's no. So let's see if we have any other. We don't have any other no. So if for some I, the maximum of last I numbers is I, it means that 1 to I are at that end, and I plus 1 to n are at the beginning. So these are going to be disconnected. That's all about the implementation of this problem. If it's clear, please let me know or use the emoji again. Unfortunately, we don't have much time left. I think we can quickly talk about how to find out the tree as well. We have around 10 minutes left. So I think we should just move on to that very quickly. Yeah, great. That's all about this. Now let me quickly talk about, okay, how to construct it now. How to construct the tree. I already have some intuition about it. Based on what we said, based on what we achieved already. What did we achieve? We said that we can just do this approach. Just start from the beginning, A1. Let's just connect A1 to everything that is greater than A1. Okay? So I can create some ranges, I can create some pairs such that I create some pairs like X and Y. I push back this to a vector. When I push back pair of X and Y to a vector, it means that I should connect X to everything up to Y. I should connect X with X plus 1, X with X plus 2, to X to Y. When I see A1, I will first push back in my vector A1 to N, which means that let's connect A1 to everything greater than A1. I will keep going. Whenever I saw some X that is less than A1, the first X that is less than A1, I will push back a pair X and A1 minus 1. I'm using inclusive intervals, but if I was going to implement it, I would use inclusive exclusive intervals. Which means that let's connect X with everything up to A1 minus 1 and also see that what is the number greater than A1 that I haven't seen it yet, also connect X to that. Okay, which is not hard. I can just say that, I can just keep that, what is the maximum of each suffix, just see that what is the maximum number after X that appears. Connect X with that too. Because we are sure that A1 is connected to that too. Just see that for whenever, our approach will be this. Whenever we see a number that is smaller than the current minimum, we set our minimum to inf at the beginning. We set our minimum to inf at the beginning. And whenever we saw something that was less than our minimum, we will connect it to everything. I can instead of inf, let's set it n plus 1 for now. Set it n plus 1. Whenever I got to some number that is less than mn, I will connect it to everything. If it is x, I will connect it to everything from x plus 1 to mn minus 1. And then for the other numbers, for example, if I saw some y here that was less than our previous mn, which is correctly x. Now I should again connect it to everything from y plus 1 to mn minus 1, which is x minus 1. Also, I should connect it to the maximum of this suffix as well. Because I'm sure that if I connect it to the maximum of this suffix, this is greater than x. And when this is greater than x, x will be connected to it as well. So first I check if it's impossible or not, similar to problem D. If it's not possible, we just output it's not possible. If it is possible, we just do this approach. Whenever we saw a new minimum, we will connect it. We will fill the gap before the previous minimum. And then we also connect it to the first number that is actually greater than the greatest number in this suffix as well. That's all. This is how we can implement it as well. And that's all about problem F. We unfortunately don't get to discuss problem E. I don't know if you have anything after F as well, but I'm glad that at least we could solve problem F. We cannot solve G and H as well, unfortunately. Can we something with DSU for 5-minute? I got to and DSU is not needed. I mean, what I'm saying is that what I'm saying could be said with DSU as well, but it's not needed because we just can add the edges offline. DSU adds the edges online, but we don't need it, you know, because we're not solving anything online. We can just add the edges at the end. DSU, all it does is adding the edges online. So I can get some trees of some. Oh, yeah. Can we just connect I and softmax of I? Let me see. That's an interesting idea. Can we just connect I and softmax of I? The maximum that appears after it. Uh that would be a bit no. For example, assume that our array is this 1, 5, 4, 3, 2. Then the only way that you have is to connect 1 to everything. You cannot connect each I with softmax of I. So for example, this would be a counterexample for that. Yeah. Offline, online. Okay, we'll talk more about it. Maybe in the roadmaps I can cover it as well. And guys, if you want, if you have further questions, I can create a post that you will ask all your questions in there. If any questions will, why am I cut off from the video? Let me create a post that you can ask your questions if you had any questions about this contest. It was 163 div 3 CF round discussion. I created a discussion page. You can ask if any questions were left that I didn't answer, you can ask it here. And I will answer them. Yeah, I just created it. This is, you can ask them here and I will respond to them. And guys, please give me feedback on the roadmaps as well. Roadmaps are the most thing that I've been focused on, and it's taking a lot of energy to write it. I mean, it was way harder than I assumed. I was like, in one day I can create most of them, but it was so harder. I mean, the small things take a lot of time, the details of it. Give me your feedbacks. You can also report any issues or suggestions about them as well. And also keep in mind these teams exist as well. If we create this community well, this can be really helpful for you. This can really help you to resolve many of the issues that you have. And if we can really do it well, if we can, I mean, if we make this community going, it can be really a great place for you to grow and finding like-minded people and many more things that would be beneficial for you. So try to use this feature. And because if more people come here, then more people are going to get benefits from it as well. Not only you, but the people who meet you are going to benefit as well, that you're going to study together, push each other. And this way it's going to be way simpler. And also today I'm going to add new problems to this problems section. I did not have time to add more problems here because of I was busy with everything. Today I'm going to prepare the sample judge for you as well, so that you can do some submissions and test the judge as well. That's also going to take some time. But I'm going to add new problems here, both for beginners and intermediates and advanced levels. If you want to be part of them and see, these are the handpicked problems. These take time to as well, because it's hard to, I mean, I really want to choose the best problems. If you want, you can say I'm in here and an email will be sent to you and you will be notified when new problems are added there. If you have any other questions, let me know. Central decomposition is hard topic. Yeah, I mean, it's based on your votes. You voted for centroid, so I mean the majority. I mean, voted for centroid, so that's why we covered centroid. But yeah, we will cover easier topics as well, and also roadmaps cover everything as well. What is the rating of D? The rating of D, I think, can be I think that that's a problem that many people might not prove it and just guess and accept that. That's why the rating will decrease. If you prove it, then you can solve F as well. Because like you saw, when we proved it, we easily came up with the solution for F as well. That's why I say like 1400, 1500. Could you present me this channel? You should take a look at RepoVive in general. RepoVive is a community. We have boot camps. Everything in RepoVive is definitely for free for everyone. It's to make the education access. It's to make this great community. The whole idea is to make this great community that everyone can grow. And we have these roadmaps that you can learn everything. If you are new, for example, to C++, you should definitely start with this C++. You should start with this C++ roadmap at the beginning if you are new to C++ as well. So just take a look at RepoVive, and if you want, you can connect with me on LinkedIn as well, and we will talk about your suggestions on RepoVive and how we can improve RepoVive and make it a platform, make it a community that would be amazing, because good is not enough. As I said, good is not enough. Good means we did not do our job correctly. Yeah, RepoVive Judge will accept all languages. It's already accepts all the languages. It's just I should do some final touches on it and the UI, and then we can. I mean, we already have the judge. It's just a bit working with the UI and small things, and then you can just test the judge. Oh, I see. As I said, I have to give up this room in 3 minutes. So if you had any questions, you can come here to post discussion of rounds, CF rounds 1063. You can send it here. And whenever you ask a question there, an email will be sent to me that you wrote a comment, and then I will respond that. So if any question was left that I didn't respond, feel free to ask it there. I will try to answer all of them by today. Sure, great. Glad to hear that. Glad to hear that. Okay, awesome. Say this in the discussions. I mean, I read it again. I will answer all of them today. I'll try to help you about that, about what you should train for problems like C2, etc. Yeah, I liked the problems of this contest. I mean, I liked the contest that they prepared in general. Where are you from? I would say guess if we had time, but because we don't have time and I should leave this room soon, I'm from Iran. C2 is just solving it. Yeah, sure things. Thank you guys for watching, and I hope that it really helped you, and I hope that we can really do more great things. See you.